Now we're going to learn something very interesting, very important too. It's called the linear functions and the slope. Linear functions and the slope. Slope is a very important concept here. Okay, so linear functions, which means when you graph the function, it looks like a straight line. We have learned this before. We have seen quite some, right? We have seen this x and a y, and here's 0, 1, and 1. This is a function, and it's a linear function, okay? And this is, I can give you a lot of examples here. Okay, 0, 1, y, okay? It's another function. Okay, 0. Okay, and we can have this one. This is also a linear function, right? And then I'm going to draw you another 3. Okay. Zero, 1, 1, and here's y. All right, I give it this 6 linear function. Sorry, this should be a straight line, okay? I'm not very good at drawing that. What can you tell? What's the difference between these 6? The first 3 on top, if you move your pen or pencil from left to right, you're going to see when x goes up, when x increases, your y increases too. See? This one, when you move from left to right, you're going up. From left to right, the curve, right, the straight line goes up. And this 3 goes down, down, down. So this are called an increasing function, and this is called a decreasing function. Any question? Nope. All right, now, even for the increasing function, we have this 3 increasing function, but they're increasing at the different speed or at a different degree. Okay, how do you describe that? Even like if you go from left to right and you're going up, and think about this. If this is a mountain, okay, and this little person is going up, so he goes up, uphill, right? And there's another mountain, it looks like this. So this little person has to go really hard to climb. All right, now both are going up, both going uphill. And how can you say what is the difference here? This is pretty steep and this is a flat, and there must be a way to give you the measurement. Mathematically, there should be like a number. We should use a number to show the difference, or we should use the number to see, how hard it is, whether it's a flat or like steep. I tell you what, we're going to use a concept called rise over run. See, if you go from here to here, and this is the rise, and that's the run, okay? And this one, from here to here, this is the rise, this is the run. If we use rise, what I'm saying, run, this is rise. I'm sorry, I don't know what I'm saying. So here's a run and here's a rise, okay? Totally opposite. So if I do rise over run, so rise over run, rise over run, rise over run. If the run is pretty much the same, but this rise is much, much greater, so we see, wow, this is very steep and this is more flat. So we call this slope. Okay, so that's a concept of a slope. Always remember this, okay, rise over run. What is rise? Rise is the change in the altitude or the change in y. And then what is run? Run is the change in x, which is from here to here. And this one, here is the rise from here to here, and the run is from here to here. Okay? So that's the rise over run. It's a slope. It's good, right? So definition slope is rise over run. In another word, change in y over change in x. All right, now if I give you this point, x1, y1, and I give you this point, x2, y2. Okay, so what is rise? What is run? If I connected them, this is the rise, right? So your rise should be the difference between y2 and y1, which is y2 minus y1. And what about your run? Your run goes from here to here. That's a change in the x-axis, so that is x2 minus x1. Therefore, the slope formula will be y2 minus y1, change in y, over x2 minus x1. Okay, so we use y2 minus y1 because we go from y1 to y2. So we use the ending point, subtract the starting point. Of course, you can say the same thing. Even you start from x2, y2, go down to, go backwards, okay, to x1, y1. You can just simply switch the order. Here is y1 minus y2. Here is x1 minus x2. You should get exactly the same answer. So it doesn't really matter you're going this way or this way, because when we talk about the slope, we always think about it from left to right. It's going up, so that's going to be a positive slope. Okay, so y2 minus y1 over x2 minus x1. Of course, if you like, you can try y1 minus y2. You should get exactly the same answer. All right, now once we know this, I'm going to ask you to do a little exercise. Okay, the first point is 2, -1, and the second point is 3, 4. Can you find the slope? If I ask you the slope of a line that passes through these 2 points, so you draw a little x0, 1. Okay, 2, -1, which is right here. 3, 4, 1, 2, 3, and go up by 1, 2, 3, 4. Okay, so this is a 3, 4, and this is 2, -1. What is the slope? Let me get it. Where's my ruler? Oh, here. So I'm going to use this. I'm going to connect that. There is a straight line here, and I'm asking what is the slope of this line passes through. So this is your x1, this is your y1, and this that's your x2 and y2. So by definition, the slope equals y2 minus y1. Do you see that? The changes in y. So 4 minus -1, 4 minus -1. Denominator, 3 minus 2. So 4 minus -1 is a 5. Okay, 3 minus 2 is 1, so the slope is a 5. That's your answer. All right, now this is your answer, but there's another thing I want you to take a look. Did you notice that in this case, our run is exactly 1? So whatever change in y will be just my slope, isn't it? Because the rise over run. If the run is 1, then whatever the rise is, that's a slope. All right, so try one more. Once you understand this, you can tell that we don't really need to graph. We don't really need to put the numbers on this plane, and then we can just quickly do that. Let's see, from -3, -1 to -2 and 4. So what is the slope of the line passing these 2 points? So that's going to be 4 minus -1 over -2 minus -3. Okay, then 4 minus -1, which is 5, and then 2 minus -3 means -2 plus 3, which is +1, so that's also 5. Sounds good? So more exercises. Let's just quickly do that. -3, 4 to 2, -2. slope will be -2 minus 4, denominator is 2 minus -3. So -2 minus 4, which is -6, 2 minus -3, which means 2 plus 3, so that's a 5. So that's your answer. Or you can just say it's a -6/5, or you can write -1/5. It doesn't matter which one because I'm pretty flexible with this. So, all right. So that is this one. All right. Now I will ask you to do 2 more. One is 1, 3. The other one is 2, 3. Slope equals 3 minus 3 on top, 2 minus 1 at the bottom. So that will be 0/1. So the answer is 0. What do you have? You have a 0 slope. I'm going to talk about this later. Okay. Next one. What is the slope of the line that passes through 2, 5 and 2, 2? So the slope equals 2 minus 5. That's the top. Denominator 2 minus 2. Wait a second. You are in trouble. Remember, anytime if you have a 0 in the denominator, you're in trouble. Okay, it's special. So if you see this, you know that we're not going to divide it by 0, right? So if you get a -3/0, then we're going to say this slope is undefined. Or you can say does not exist. It doesn't matter which way you write, both are correct. So the slope is undefined or the slope doesn't exist. Okay, let's take a look. What is going on here? Why these two are so special? The first one, we have the point 1, 1, 2, 3, and that's y. So that's a 3. 1, 3, 1, 3. Okay, another point 2, 3. Did you notice that if you connect this, you get a straight line, which is the horizontal line? Horizontal line. And what function is this? It's a constant function, isn't it? For constant function, that slope is 0. All right. So when you climb a mountain, if I tell you that in certain interval, the slope is 0, what does that mean? That means it's a flat. You're not going up, you're not going down. If you're going up, you get a positive slope. If you're going down, you get a negative slope. And a 0 means flat. Okay, slope 0. So I think you're going to be super happy. Okay. All right, now what about the next one? The next one says 2, 5 and 2, 2. X 1, 2. 1, 2, 3, 4, 5. Okay, so 2, 5, which is right here, and the 2, 2 is right here. If you connect these 2 points, hey, you get a vertical line. And of course, it's not a function, right? It's not a function. We're not past my vertical line test. It's not function, but this line, is there any slope? Well, it's like a cliff. So this slope is undefined. If you have a line look like this, that's a positive, that's a 0, no, or you cannot say no slope, okay? Just say 0 slope, and it goes greater and greater and greater and greater, it goes huge. You get a very, very big slope until you get this, then that's undefined. And then if you keep going, then that's a negative slope, but it's a very, very negative number. And then it goes still negative, but closer to 0 until here you get a 0 slope. And then keep turning, then you get a positive slope again. All right, so that is the 2 special case, right? That's the vertical line and or undefined slope, and the other one is 0, slope 0, or it's a flat line or 0 slope, horizontal line. Okay, so now what you need to know is the definition of the slope, and also if I give you 2 points, I give you both points as x and y coordinates. You should be able to tell me what is the slope. All right, now next one, I'm going to talk about the two different forms of a linear function. The linear function could be look like this: ax plus by plus c equals 0. This is called the general form. General form has a 0 at the right on the right side. So this a and b, one of them could be 0, but a and b, they are not both 0. If both are 0, then they don't have this term. It's not a line. So you have x term, you have a y term, and you have a constant term. That could be 0. But anyway, if you have something look like this, equation look like this, that's the linear equation. The other one is called this. It's y equals mx plus b. You might be more familiar with this one. This one is called slope and intercept form. What does that mean? That means this guy is my slope, and this guy is my y-intercept. Now, quick review. What is y-intercept? Y-intercept is the value of y when x equals 0, isn't it? When x equals 0, you plug in 0 here, mx equals 0, y equals b. Yes, that b is my intercept. Once you have the equation, looks like this. This is a linear equation, and that has the y-intercept b. All right, now the reason I give you this two form, we're going to deal with this first, and we'll talk about this later, okay? For slope and intercept form, you think about a line. Think about the line. If I give you 2 points, if I give you a point 1 and a point 2, x1, y1, x2, y2, can you give me the equation of that line? If I give you 2 points, x1, y1, x2, y2, can you give me the equation? Sure, because if you use y2 minus y1 over x1 minus, y2 minus y1 over x2 minus x1, rise over run, changing y divided by changing x, you get the slope. That's the slope. You already have the slope. And once you know the slope, then you can just plug in whatever given point. I give you 2, you can just use either one. And then put in the x value, y value, you already know the slope. Solve this equation to get a b. If once you know m, once you know b, you have the equation. Isn't it nice? Okay, so given x1, y1, and x2, y2, then you find the slope, that is m, okay, and that would be y2 minus y1 over x2 minus x1. All right, and then you just do y equals mx plus b. Remember, that's the form that we're looking for. So you can just plug in your either, let's do x1, y1. So when x equals x1, y is y1. So y1 would equal to m, we already know that, x1, then plus b. So you know x1, you know y1, you know m. Then you can just go ahead and find b. You get it? Okay. So that gives me another one. That gives you, so let's see. Given x1, y1, so given 2 points, you're good, okay? All right. What about this? What about I give you given 1 point and the slope? Is this line fixed? If I give you a point and I give you the slope shows the direction. So if I give you the point, which is x1, y1, just there's only 1 point, okay, and then I give you the slope, so this line is fixed, so which means m is known. Okay, again, this one is just one step less than that. It's much easier because you already know the m. Again, the same thing you put in here. All right. So you can do m equals y minus y1 over x minus x1, or y minus y1 rise over run, okay, equals m times x minus x1, and then you bring y1 to the other side, so your y equals, distribute this, or you can just keep it, x minus x1, then plus y1, and then once you know x1, y1, and m, you just plug that in and you can get the equation. So this is called a point slope form. It's just a little different, but it's really not hard. Okay, what about for the horizontal line? Remember, for horizontal line, the slope is 0, so which means y equals mx plus b, so that m is 0. Therefore, the equation looks like y equals b. Okay, and for vertical line, vertical is not a function, and that will be x equals a number, and it's not a function. Just x is a constant. X is the same number no matter what y is. Horizontal line means whatever x is, our y is always b. So that is, here's a b, and you get this line, okay? And this one is x equals a. So here's a. Make sense? All right, now based on all those things we learned or we know, we're going to be able to work on a lot of things. Let's see. If I give you point and slope, can you find the equation? Or if I give you 2 points, can you find the equation? Let's work on the example 1. Example number 1, or exercise number 1. I give you slope equals 4, and it's going to passing through -1, 3. So you know that once you know the slope, you have a point, you have a slope, that line is fixed. So which means m is 4, okay? And -1 and 3, that is my x1, y1. So remember what the formula looks like? M slope is rise y minus y1 over run x minus x1. The good thing is I know x1, y1, and m, so I just plug that in. So 4 equals y minus 3, because y1 is 3, over x minus -1. All right, so that means 4 equals y minus 3, denominator is x plus 1. And then I need to multiply by x plus 1 on both sides. So I go multiply by x plus 1, and this side I go x plus 1, right? So this canceled out. So what do I have is, I distribute this to 4 inside. Can I do that? I go 4x plus 4 equals y minus 3. And remember, for the usually we use a slope intercept form. So we keep y on one side, and the x term and the constant term go to the other side. So, but this side I already have y on one side. Let me write that, because I put that on the left side. I just switch both sides. So 4x plus 4, and then I just need to plus 3 on both sides. Therefore, I get y equals 4x plus 7. This is my equation. The good thing about that is you can always verify, because look, here's the slope. That's what we know. And when x equals -1, y should be 3. Is that right? When we plug in x equals -1 here, so 4 times -1, which is -4, plus 7, yes, it's a 3. So I'm done. Now this is how you find the equation of this line given slope and a point. Now I'm going to work on the next one, my exercise number 2. I ask you to give me the equation of the line that passes 4, -3, and -2, 6. Once you're given 2 points, you can just leave yourself a little note. You don't have to, but I think I just write it here just for you, easier to remember. If you have 2 points, what's the first thing you need to do? Get the slope. So m will be y2 minus y1 over x2 minus x1. The difference or the change in y, which is 6 minus -3. You see that? 6 minus -3. Denominator is -2 minus 4. Okay. All right. So that is 6 minus -3, which is 9. And then the denominator is -6. So the answer is negative, and both numerator and denominator are divisible by 3. So we simplify this fraction. I get a -3/2. So I get the slope. And once I know the slope, then remember the slope, -3/2 will be 1 minus y1. There are several ways to do it, x minus x1, which is exactly the one we did earlier. Or we know y equals mx plus b, so I plug in this. So y will be -3/2 x plus b. And then I can plug in x1, y1. So y1 is -3, and here's -3/2 times x, which is a 4, and then plus b. Okay, so this, you're going to cross this out. You have a 2, so that's -3 equals -6 plus b. And then you plus 6 on both sides. Plus 6. Therefore, your b is 3. You know m is -3/2. You know b is 3. I'm sorry. So the equation looks like this. Y equals -3/2 x plus 3. So this is the way to do it. Or you can just put in here. So that's going to be -3/2 equals y minus. So even I put here x1, y1, you can also put x2, y2. Let me just do that. Okay. So x2, y2. Okay. I want to show you that it's the same. So y2 is 6, and x2 is -2. So it's going to be x minus -2. So that is y minus 6 over x plus 2. All right, we're going to cross multiply. So 3 times, or I can put the, because there's a negative number, so I can put the negative on top, make it a little simpler. So -3 times this, I get a -3x times x plus 2. Cross multiply, right? That equals 2 times y minus 6. You see? Then I get a -3x minus 6 equals 2y minus 12. All right, now I switch the side because I like to have y on one side. So I get I'd better use a new piece of paper here. Okay, so I got a 2y minus 12 equals -3x minus 6. I just switch left and right, and a plus 12 on both sides. So I get a 2y equals -3x plus 6. I need a y, so I have to divide it by 2 everywhere. So therefore, y equals -3/2x divided by 2. I get a 3. Okay, see, that's my answer if I use this. Did you see? It's exactly the same answer. So it doesn't really matter which method you're using. You should give me exactly the same answer. Okay? Sounds good? All right. Now, next one, I will ask you to give me the equation of the line that passes through 2 points. 1, 2, and 3, 2. Did you notice something? Slope equals right m, that's a right over run. Changing y, 2 minus 2. Changing x, 3 minus 1, you get a 0. So that's a flat line or constant function. So that is y equals to a constant. What is that constant? 2. See, y is always 2, doesn't matter what x value is. Sounds good? Okay. All right, now what about a graph? If I give you a point and a slope, how do you graph? Let me see. I give you a point. Point 0, -2. Okay, and I give you a slope. It's a little tricky, isn't it? Can you graph it? Well, of course, if you know the point, then what is this? That's your y-intercept, isn't it? That's a y value when x equals 0. Did you see that? I even didn't mention that. And you should be able to tell. And that is hard. But anyway, so when I say just graph, I'm not asking you to do too much. 1, 2, 3, 1, 2, 3, and y. Here's 1, 2, 3, 1, 2, 3, and here again -1. Okay, so where is the point 0, -2? Which is here, right? So I give you a point and I give you slope. Can you graph it? Can you graph it? You are, okay, so there's one way is given point, given slope, then you find the equation and then you plug in x equals whatever number and then you find that corresponding y, so you get at the second point. This is the first point, you get at the second point and you connect them. That's one way to do it. An easy way, another one, easy way. Once we know the slope, slope is 3. What is the slope? Rise over run. Okay, slope is rise over run. What happened when run equals 1? Then that rise is just the slope itself, isn't it? Okay, so therefore, slope is 3 means when x increase by 1, y will increase by 3. When x increase by 1, which is the run, when the run is 1. So when x increase by 1, y will change by the amount of that slope value. So here is x equals 0. When x increase by 1, and then the y will increase by 3. So go from here 1, 2, 3. So that's the point. See, x go from here to here and y go from here to here. Did you get the second point? You do. Once you have the second point, of course you can just graph it. If I didn't ask you the equation, then you don't really need to, but this is the fast way to get the graph. Okay. And the other way is if I give you 2 points, can you graph it? I think that will be the easiest work in the world because you just need to plot these 2 points. So 1, 2, 3, 4, 1, 2, 3 here. That's the x, here's a 0, 1, and here's y, and then -2, 1, 2, 3, 4, 5, 6, -2, 6, 4, -3. There you go. Okay, so that's the easiest part, right? If I ask you to graph this, hey, that's easy. All right, now we go back to the general form. If you remember that we talked about the general form, and I said I'm going to talk about this later. If you are given this form, unfortunately, and I ask you to graph, you know how to do it? So for example, if I give you 2x minus 3y plus 5 equals 0, can you graph it? If you want to graph a line, you need 2 points. Okay, or you need a point with a slope. So a couple of ways to do it. The first one is pick x value and then find what is the y value. Okay, so that's the easy way to do it. Okay, and then you find the 2 points. You only need 2 x values. For example, you know what I like to do? I always like to choose x equals 0, and the other one I choose y equals 0, and then I find the corresponding y and the corresponding x and then graph. So what happened when x equals 0? So this part is 0. Okay, so that's going to be 0 minus 3y plus 5 equals 0. So 3y, I bring 3y, that will be 5. So y will be 5 over 3. Okay, So that's going to be 5 over 3. And what happened when y equals 0? So this part is 0, therefore I get a 2x minus 0 plus 5 equals 0. So 2x equals negative 5, and x equals negative 5 over 2. So negative 5 over 2. Did you see that? I get 2 points. Okay, so I can do x, okay, y, and 0, 1, 2, 3, 1, 2, 3, and then 1, 2, 3, 1, 2, 3. The first point is when x equals 0, y equals 5 over 3. 5 over 3 is about a 1.6 or 1.7, so it's about here. And this one, when y equals 0 and x equals negative 5 over 2, that's negative 2.5. So I get this 2 points. Pew! I got my graph. What do you think? Not bad, huh? All right. And of course, I said there's another way to do it. The other way is you do this. 2x minus 3y plus 5 equals 0. And then I leave y on one side because this is negative. I bring that to the other side. Then I switch the left and the right. So I get a 3y equals 2x plus 5. Okay. If you're not with me, then you want to pause and think. Next, I'm going to divide by 3. So y equals 2 over 3x plus 5 over 3. Slope, y-intercept. Okay, you see slope, the y-intercept of 5 over 3, and slope you can do 1, 2. Slope is 2/3. So when slope goes up, when x increases by 1, then this goes up to 1/3. So it goes here. All right, so this is just another way to graph, but this is a very popular, I would say. There you learned, if I give you the general form of a linear equation, how to graph it. Okay, so that's all for this section.